In question 7, we have a particle projected in a straight line from a fixed point O with initial velocity u going in this direction. Initial speed, and it's opposed by a resistance k v to the power of q. And q is a constant and it's between 0 and 1. If s is the displacement from O when the particle comes to rest, okay, so we need velocity equals 0 at some point. Prove s is equal to this thing here. So let's see what we know. Set up our forces is equal to ma. So we're going to have a resistance of minus kv to the power of q. Minus kv to the power of q. It's going to come to rest equals ma. And I forgot my m over on the left here. So minus kv to the power of q is equal to acceleration. We're going to use v dv ds here. I think we're using displacement. So minus kv to the power of q is equal to v dv ds. So we're going to get minus k ds is equal to v dv divided by v to the power of q, and that's to the power of 1 on top. So that's where we're going to get that indice going on. Minus k ds is equal to v to the power of 1 minus q if I bring it up dv, and that makes it a little bit easier to integrate. So what have we got going on? Straight line, initial velocity u. Okay, so initial velocity u, and it's going to come to rest. And starting from 0, we'll find its displacement. So we're going to get minus ks on the left hand side. We can put in the 0 if you want. Is equal to, we increase the power by 1 and divide by the new power. We're going to get 1 minus q will go to 2 minus q, because we're just adding a 1. Then we're going to divide by the new power, and that will be between 0 and u. So minus ks is equal to, it's going to be 0 on top, so it's going to be 0 for 0, and then we're going to get minus, maybe put the minus outside the bracket, we're putting u in for v, so we're going to get u to the power of 2 minus q over 2 minus q, and we can change them both to pluses or multiply by minus 1 at this point. So we're going to get displacement to be u to the power of 2 minus q over 2 minus q, and we're going to have to divide by k, so divided by k. So that's what displacement is, u to the power of 2 minus q over 2 minus q times k, u to the power of 2 minus q over 2 minus q times k. That's the end of this question.